This is a tutorial that deals with the last part, that's section C of the electromagnetism chapter. Again, it's slightly tricky. It deals with electromagnetic induction, the working of an AC generator, transformers. So here you can see we got a video ready here. It's by the same person as the last tutorial. I don't know how to say his name, but there it is. Uh, Also, I don't think in the last video you could see my cursor where I was pointing in the video, but I think you could now. I'm not sure, and I've tried to put a sort of highlight around it so you can see exactly where I'm pointing. So here you can see the name of the video, electromagnetic induction. If you just look at the video and just observe what's happening, the wire in white over here, I'm going to make this bigger. Yeah, the wire in white here is your conductor. The red spheres which are moving around, it's just signifying the charge that is moving around the current. uh, Now also this is your magnet, of course, north south, and all that's happening is you're moving this magnet towards this conductor. You're moving it back and forth, and just keep in mind that over here we're only keeping the north towards the conductor. So I think you would have done this. You'd be familiar with the concept that if you have a current, I'm going to draw it here. You have a coil like this, or a solenoid if you want to call it, and it's getting coiled behind. See, this is your face over here. So now if your current is moving in the clockwise direction, that means that if this is solenoid, this would be the south face. While if this was the north face, it would be moving in the anti-clockwise direction. So now going back to the video, if you look at this as if you're the magnet, you're the north face of the magnet over here where I'm keeping my arrow, just imagine the conductor, you're facing the conductor. So I'm going to draw it here. It's something like this. That's how it looks. Go back to the video and you see, let's just wait for the magnet to come back to the original position. Okay, here. Oops. Okay, let's try playing it again. Yeah. Okay. Now we're moving the magnet with the north face towards the conductor. So what you see is that the current is actually moving in an anti-clockwise direction. See if you can see it. It's moving downwards like this. So if you're the north face, it would be something like this, and this matches this diagram over here. Similarly, now if we play this, now we're moving it away from the conductor. So what you will see now is that the current is in the opposite direction, it's moving in clockwise. Just look at it there. So now it's actually something like this. Compare it and you'll see that it fits this diagram. So this is when you're moving away, and this is when you're coming towards it, going closer, let's say. Also, one more thing you should note, at the instant where it reaches its initial position, your charge actually remains stationary. I'm going to play it and you'll see that when the magnet comes somewhere here, which means right next to the conductor, the charge, the magnet will stop for a moment, and at that moment the, the charge, the red spheres over there will stop moving. You can see that now. There you go. That's a little pause. It's not a long pause at all. It's less than a second, but it is there. So from that we can say that when the magnet is not moving, when it's stationary, this is your magnet. When this is stationary, it's not moving, then there's going to be no charge. No charge. no current, no induced EMF. Sorry, this looks like one word, but it's no charge when you're not moving the magnet. Okay, now, so if you want a way to remember these two over here, it's the easiest way to remember it is that when you have the north face coming towards the conductor will want it to go away. So what it'll do is develop a like charge. So it'll develop a north so that these two get repelled. And this indecisive little coil over here, when the magnet is moved away, when the north goes away, it'll want it to come back. So it's going to develop a south then. That's the easiest way to remember it. Just match it over here. When north comes closer, it develops a north, which is this case over here. And when the magnet moves away, it wants it to come back. So south over here. This is that case. Now, similarly, I'm going to just bring up the video when you have the south face facing the when you have the south face facing the coil. Here it is, same thing, except everything gets reversed. So you can see when you're moving the magnet away, it's anti-clockwise. So when you're moving away, it's anti-clockwise. Anti-clockwise means it's north. So the same rule applies. When you're moving the south away from the coil, it wants the coil to come back, so a north is developed on that face. And similarly, if we bring up, we pause here now. When I play it, you will see the south coming closer. So you can say that the coil will want to repel the magnet away. So it'll develop a like charge, and so it'll be a south charge on this face over here, and hence the red spheres will start moving in a clockwise direction. There you go, they're moving in a clockwise direction. And same thing applies at the closest point, which is somewhere here. Yeah, there's a little pause over there. Even when it reaches here, you'll see a little pause. At that point, the red spheres do not move, indicating no current. So that's it really. This is electromagnetic induction. Just a few rules that you need to follow. The thing I told you about moving away, it attracts it, and when the magnet comes closer, it wants to repel it. And just remember, clockwise is south, anti-clockwise is north. And I think you can just visualize this example over here. That's the best way to do it, really. Um, Nothing else under electromagnetic induction. Only a few more things. Again, only when there's motion, relative motion between the coil and the magnet, only then will there be any current at all flowing. Otherwise, there'll be nothing. And if um, if we reverse the magnet, say north comes here, south goes there, then everything else will also get reversed. Like the current will start going in the other direction, and say you're bringing the south closer, and you're taking the south away. Even there, it'll be reversed. Also, a few more, just one more thing. The factors on which the current in the coil depends. You'll see that current will increase if you start bringing the magnet to it in a rapid motion. If you start bringing it really fast and moving it away very quickly, the current in the coil will increase. Also, if you use a stronger magnet, naturally it will increase. And as usual, if you increase the area of the coil or the number of turns, so the length of the coil will increase, and so the current will also increase over there. So that's all you need to know here. I'm approaching the 10-minute mark, so as usual I'm going to carry over to the next video where we'll be doing just a bit more of electromagnetic induction, and then we move on to the AC generator.